Today, we will be investigating measuring matter in our blue NISA review packet. Please open up your packet to the very first page. You will see it titled Measurement Review. Before we can talk about measuring matter, we first need to determine what is matter. Look at the images on the top of the screen. A soccer ball, clouds, a race car, you. All of these things are matter. What is matter? Matter is anything that has mass and takes up space. Let's talk about how to measure mass. Mass is really looking at the amount of matter inside of an object. What unit do we use when we're talking about measuring mass? If you said kilogram, gram, or milligram, you would be correct. These three things you need to write down under units for mass. The one unifying thing you should see here is that whenever we're measuring mass, we always use the unit gram. Kilogram, milligram, decigram, it always is grams. But what about the tool that we use? Which two tools can we use for measuring mass? Do you see a theme here? Both objects have balance in them, whether it's a triple beam balance from when your parents went to school or the digital balance in our classroom. Both objects are using a balance. When you talk about balance, it comes back from its way ancient times where you had scales, right? Where you would have known masses on one side and an unknown mass on the other. And the goal was to get the two sides to balance out. Now that we've looked at measuring mass, let's take a moment to measure length. In order to measure length, we must first determine what tool is used to measure length. The tool that is used is a meter stick, which gives away the answer for what units we use when we're measuring length. The units for measuring length would then be meters. Now, just like grams for mass, you can have kilometers, centimeters, millimeters, and we've used all of these in our science class this year. So, let's take a moment to answer the first question below. It says, which is larger? 1 meter or 105 centimeters? 4 kilometers or 4,400 meters? 12 centimeters or 102 millimeters? Or 1,200 millimeters or 1 meter? Which of these would be correct? If you answered 105 centimeters for A, you would be correct. If you circled 4,400 meters for B, you would be correct. And if you circled 12 centimeters for C, that would be correct too. And for D, you should have circled 1,200 millimeters. Let's review length in a little bit more detail. On your sheet, you will see that you too have this exact same image. I want you to measure the length of both of these lines. Tell me, what is the length of the line in centimeters? And what is the length of the line in millimeters? Notice for line number 2, there's a hint. It says round to the nearest centimeter, no decimals. Let's now look at how to measure the volume of a regular solid. How do you find the volume of a regular solid? First off, you should indicate on your sheet that the tool used to find the volume of a regular solid is shown here in this image. It would be a meter stick. And then you can also see that the second question on your sheet has been listed for you. How do you find the volume of a regular solid? Through using the equation, length times width times height. And what units would you use? Now, don't forget, you have 3 measurements coming into account here. You measured the length you measured the width, and you measured the height. So when we look at the units, you need to take all three of those measurements into account. Hence, we use things like centimeters cubed or millimeters cubed. The key word here is cubed. Because you did 3 measurements, you should have a 3 coming after your units. And now let's look at measuring the volume of a regular solid in more detail. Notice it says practice finding regular solid on your sheet. What I would like you to do now is indicate the length, width, and height of this cube shown to you, and then calculate the volume. Now let's look at measuring the volume of an irregular solid. Remember, irregular solids are objects that do not have definite sides to be measured. So how do we measure them? If you said the water displacement method, you would be correct. And what tool would we use to find an irregular solids object? A graduated cylinder or beaker would be the correct answer to write on your sheet. Now let's practice this. Look at the image on the bottom of your sheet. Do you see how it says practice finding irregular volume? What I would like you to do now is read how much water is in graduated cylinder number 1. Also, look at how much water is in graduated cylinder number 2 now that the rock has been submerged within it. In order to find the volume of the unknown object, you would have to 1. Take the amount of water with the object in it and write it on the first line. Then take the measurement for the amount of water without the object in it and write it on the second line. To find the volume of just the object, the rock, you would take the difference between the water volume with the object in it and without the object in it. Please record your answer on the third line. Now for something a little bit easier, because you've already been doing it. Let's look at how to measure the volume of a liquid. Now, here's something to keep in mind. Whenever we are reading the volume of a liquid, we must take into account a meniscus. Remember that a meniscus is the curve that occurs at the surface of a liquid. Remember, when we are using a graduated cylinder, you must always be at eye level with that liquid. Another thing to take into account is we always read the bottom of the meniscus. So, what is the volume of water in this graduated cylinder? If you said 43 milliliters, you would be correct. Now let's do some independent practice. Notice on your sheet, there are 2 images. You can see here is the image indicated for you on the left, and then here is the other image indicated for you on the right. What I would like you to do in your packet right now is determine what is the volume of both of these liquids. Now let's talk about weight. Remember that weight is the amount of mass inside of an object along with the gravitational force pushing on that object. So when we are measuring weight, what we're really looking at is mass times gravity. And what unit do we use for weight? Well, the unit is newtons. Please make sure you write newtons in your note-taking packet. And now let's talk about what tool is used to measure weight. I want you to think about when you're at a grocery store and you're finding the weight of the apples that you might be purchasing, or when you go to the doctor's office and you step onto an object to find your weight. What is that object? If you answered scale, you would be correct. Now in science, we use something that's called a spring scale. And a spring scale is measuring the force of gravity exerted on that object. Notice, you can actually see the springs inside of the spring scale. Don't forget to write that we use a spring scale when measuring weight in your note-taking packet. And now let's spend one last moment looking at density. Density. Oh, remember how much you love density? Remember that density is the amount of matter in a given space. So what's the equation for density? Well, just remember that you love it. Because remember, density is a heart with an arrow through it. And if you can remember that, you can remember that density is really mass, which is the top of the heart looking like an M, divided by volume, which would be the V on the bottom.